Hey folks, welcome to the Neo4j stream. My name's Will. Today we are picking up with episode 2 of building GRANDcast FM, which is our podcast application built using GRANDstack. We're going to pick up from where we left off last time. Let me link the code if you missed the last one. Is this it? Yeah, this is it. So I'll drop this link in the chat. So last time we started, actually, let's just look at this in blog post form. Maybe that's a good way to review what we did last time. So the recording from the live stream and then also sort of a blog post write-up is linked there in the GitHub README as well as the code. But basically what we did last time is we started out with a graph data modeling exercise where we said, okay, we have sort of the business requirements of our application. We know we want it to be a podcast application, so I want the user to be able to do things like search for podcasts, subscribe to podcasts, create a playlist, add episodes to a playlist, this sort of thing. So we went through this graph data modeling exercise that I like to do whenever I start off an application. Start from the business requirements and then go through this process. Okay, what are the entities? These become the nodes. How are those entities connected? Those become the relationships. What attributes describe these entities? Those are our node properties. What attributes do we have that are specific about how those nodes are connected? Those are relationship properties. And then sort of we use this arrows tool, which I like to use, which is this fairly simple online diagramming tool that lets us create these graph models. And then the question we ask ourselves is, okay, can I imagine a traversal through this graph that answers the questions that I have that drive the business requirements of the application? Like, can I imagine with this model how I would show a user all of the episodes in a playlist that they subscribe to? Once I start to sort of think about those traversals, if I can traverse through the graph to answer those questions, okay, good. That's a good model to start my implementation with. If not, then I might want to iterate the model a little bit. So graph modeling, I think of as a bit of an iterative process, and that's okay. So once we came up with our graph data model last time, the next thing we did was implement podcast search. And there's lots of different ways to do this. We could have gone out and start to build our own sort of podcast index and build search on top of that. But there are a few services that provide that. The biggest one is probably Apple iTunes. But there's also this API called the Podcast Index that also maintains an index of podcasts and has an API that allows us to search for episodes. So we looked at that endpoint. We wrote a Cipher query using a bunch of APOC procedures and functions. So namely APOC load JSON params, which lets us pull down JSON data from like a file or another API endpoint. It lets us attach headers, so we need to attach authorization headers, and we use some other APOC functions to be able to construct and work with that result, all within Cipher. We stored our podcast index API credentials in a configuration file, then we pull those in using APOC static get, so we don't have to save our podcast credentials in our Cipher query. So we did that in Cipher, which is kind of fun to query another API using Cipher. Then we created our GraphQL API. So we used the create GRANDstack command line tool to give us the skeleton of our API application. We chose just API only. The create GRANDstack app CLI can also provision front ends for us as well, using React, Flutter, Angular. There's also a Vue implementation. But we just are focused on the API for now. And then we took that Cipher query for querying the podcast index, and we attached that into our GraphQL schema using a Cipher directive. We're going to do a bit more with Cipher directives today. These are a really powerful way to add custom logic to our GraphQL API using Cipher. So we'll see some examples of that today. And then this gave us a GraphQL API that was then able to search for podcasts. And if we query that, we got back podcast results. And that was it. That's where we left it off last time. So let's, first of all, fire up our GraphQL API. Local server running 4001 GraphQL. And here we go. We can see we have one entry point query field called podcast search. That's going to give us list of podcast search result objects. We search for Neo4j. We find the Neo4j podcast. We can also bring in things like the feed URL and artwork. Search for other terms. We search for connected. Yep, we get the connected podcast. Cool. So that's where we left off last time. What I want to focus on this time is now allowing users to be able to subscribe to podcasts, right? So we've got search. I can search for podcasts. Subscribing to a podcast is the next sort of logical thing that a user will want to do. So we'll implement that feature next. In order to enable a user to subscribe to a podcast, though, we need to have the ability for users to sign up and also to log in to our application. And because we're just focusing on the API at this point, we'll still just work on the GraphQL API and implement these features in the GraphQL API. We won't start the front end today. Maybe we'll do that next time, or maybe down the road a bit, but we'll get there eventually. So we need to have the concept of a user. A user needs to be able to sign up, to log in, and then make authenticated requests to subscribe, because I want to make sure that a user is only able to subscribe themselves, right? I don't want a user to be able to subscribe some arbitrary other user to a podcast, and then when I view my list of subscribed podcasts, I only want to show the podcasts for the currently authenticated user. Cool. So that's what we're going to focus on today. Let's talk a little bit about how we're going to do that. So previously, we used Auth0 as our authentication service and also took care of our user database, essentially. And when I say previously, this was in the Willow GRANDstack applications. This was our real estate search application. So if we look at, if you want to see sort of how we did this, there's a couple of the recordings linked here. So taking a look at exploring authorization and then adding GraphQL authorization with Auth0. These are the recordings from the live stream for this project. And we used Auth0 in a few places. We used it in the front-end application. So there's a great React library for Auth0 that handles the auth flow, the storing of the token, refreshing a token from the server when it expires, all these sorts of things. So there's benefits from the front end, but also on the back end, a service like Auth0 is nice because we then don't need to worry about how to handle user passwords. If we're doing something like an OAuth flow, so sign in with Twitter or Google or something like that, Auth0 has implemented that flow for us. And then Auth0 also maintains our database of users, so we don't need to really think about maintaining that. And what we get from Auth0 after a user signs in is an authorization token, typically a JWT, JSON Web Token. So I like to think of Auth0 as like a JWT provider almost, because really that's what I'm most interested in, is getting that token and then decoding the token to figure out, okay, who is this user? What permissions do they have? And so on. So a question from the chat: how can I create a database in Neo4j? I downloaded Neo4j, launched it via command line, opened the web interface in a browser, but I can't understand where to create the database. So by default, Neo4j, so if we open up browser, I have a database running at 7474 as browser. So this is, I think, the web interface that you're referring to. This is Neo4j Browser, which is like a query workbench for working with Neo4j. So by default, here you can see in this dropdown, you have multiple databases to choose from. The system database, this is one for like maintaining lists of databases and so on. So by default, you have the Neo4j database. So if you want to start using Neo4j, there's a default database created. If you switch to system, you can do things in browser like :dbs that will show you the list of available databases, use Neo4j, and then I can do things like create database foobar. Let me make this a bit bigger. So create database and the name of the database. Now in the dropdown, I have 3 different databases to choose from, so I can choose which database I want to work with in the dropdown to switch back and forth, or I can do this :use command. So now I've got a database. If I create a node here, create a node for myself. So here I've created this node in the foobar database. If I switch back to Neo4j, that database is empty. So that is how you can create databases. If you're just getting started, though, you can just use the default Neo4j database. The developer guide might have some more information. This might be a good place to start to take a look at the graph platform database. This might be a good place to start. If you're working with Neo4j Browser, this also might be a good place to start. So I'll link both of these pages in the chat. That might be helpful. You can also use Neo4j Sandbox, which is my almost like default way to start with a database these days, because I can just have it created and hosted for me for free and build applications against it. I don't have to think about how to deploy my database somewhere. Cool. Hope that's helpful. Uday in the chat. Hey, Uday. How's it going? He says, I have Auth0 implemented, but I'm looking for an alternative as it is cost prohibitive. Any recommendation? Yeah. So this should be an interesting one and relevant for you today because we're not going to use Auth0 today. So I was talking about how previously we used Auth0 and it was kind of this like token provider for us that handles authorization and it handles our maintaining our user database and just gives us this token so we don't have to think about a user has to reset their password, a user wants to sign in with a different service, this kind of thing. All that's handled by Auth0, which is quite nice. But yeah, there are reasons why you might not want to use something like Auth0. You may want to implement this functionality yourself. And so that's what we're going to do today. So we're going to add the ability for our users to sign up, to register, and for our users to log in without using Auth0. Instead, we are going to maintain our database, our user database ourselves. So we're going to store user information in our database along with our podcast information. That means we're going to have to work a little bit with user passwords and generate our own authorization tokens that after a user logs in, we can then hand to the front-end application so that their requests to the API will use that token and then be authenticated. So we're going to use a couple of libraries to do that. Let's take a look at a couple. First one we're going to look at is Bcrypt. So Bcrypt is an algorithm. This is a library that implements the Bcrypt hashing algorithm. Has a handy Wikipedia page that I'm sure goes into a lot of detail. Bcrypt will hash, so this is a one-way hash of a user's password. So when a user signs up, we're going to ask them for their username and for a password, but we don't want to store that password in plain text in the database. If someone hacks our database, then they have everyone's password. That's no good. So what we want to do is create a one-way hash of it so that then when a user goes to sign in, we take the password that they're trying to sign in with, we hash it and compare it to the hashed password in the database. If it matches, then we let them log in. So that's one library we'll be using. We will also be using the JSON Web Token package. And the JSON Web Token package will let us do two things that we're interested in. One, to create a token. So once a user has signed in, we then need a way to sort of cryptographically sign that this user has this user ID and this username, right? So basically like a way to cryptographically sign that, yes, this is the user who they say they are, and allow that user to make authenticated requests against our API. So we'll use this JSON Web Token package to create our token, and then also when we have requests coming in, to decode that token and make sure that one, the token was signed by our application, and then also to inspect what are called the claims of the token to figure out who the user is, essentially. If you're not familiar with JSON Web Tokens, there's a great site, jwt.io. that has this fun little debugger. So here it generates this token for us. So here's the token, and here's the decoded form of that token. So a token has three parts. When it's decoded, it has the header, the payload, and then the signature. The header just says basically what algorithm was used to sign it. It's the payload data that we're interested in our application. So these are sort of the default elements of a token. These are called claims, also in the payload. And a JSON Web Token is basically just a JSON object that is then encrypted into this token. So we're just encoding this JSON data in this token, and then we can pass around that token to essentially pass along this information. So we can add something like this user's name. You can see how the token is changing. Maybe also this user has a username, Bobby Tables. And then we can take this token, and if I'll just open up another window of this, but this is what we're going to do in our API application. We get this token, we decode it. Oh, yep, here's the username and user ID. I'll go look up this user in my database. So that is what we're going to use for our authorization token, these JWTs, JSON Web Tokens. Okay. Let's go ahead and get started then. So here is the code. And by the way, feel free, if you have any questions or thoughts, feel free to drop them in the chat as we go along. So the first thing I'm going to do is go over to my GraphQL schema. Let's leave the terminal up. Let's just minimize that. There we go. So here's the GraphQL schema that we created last time. Let's give ourselves a little more screen real estate there. So we have our query type that has podcast search as a query field. The logic for that is defined with the Cipher query that's using APOC to search the podcast index, and it's returning podcast search results. Cool. So let's start off by creating a mutation type. And I want two things on this mutation type, two fields. The first is going to be sign up. And this will take a username and a password. I guess we should make these required strings, since a user can't sign up without giving us a username and password. And this is going to return, let's call it an auth token. So we need to define what this auth token type is. Let's say it just has a token field. That's a string. That seems like a good place to start. So that's for sign up. And then also we'll have login. That takes a username and password and returns an auth token. Okay, I think that's all we want to change in our type definitions for now. Let's jump over to index.js. And let's get our terminal back, so I need to install some packages here. So let's npm install JSON Web Token. That's this package that we were just looking at. And then also install Bcrypt, which we'll use for hashing passwords. And then we're going to import JWT from JSON Web Token. And then from Bcrypt, there are two functions we're going to pull in here. If we go back, there's a compare. So compare is sync or async. I think we want the synchronous version. That'll work a bit nicer, I think, in our resolvers. So compare sync. So this is when a user is logging in and we want to compare the password that they've given us with the hashed password that we've stored in the database. And then in order to create the hashed password in the first place, we'll import the hash sync, the synchronous version of the hash function. Okay, so now what we're going to need to do are implement the resolvers. So we haven't implemented any resolvers yet, and if you've seen us use the Neo4j GraphQL.js library, we oftentimes skip that step because we get a lot of those resolvers generated for us as part of the Neo4j GraphQL.js library. But we're going to have to write some resolvers today because we want to be able to deal with hashing passwords, generating auth tokens, and so on. That's fine. So let's start with our sign up resolver. So every resolver is passed 4 arguments. The object, this is the object that's currently being resolved, that has been resolved up to this point. So resolvers are typically called in this nested fashion. This is the root resolver. So this first argument object is always going to be an empty object. Then we have args. So these are the field arguments. In this case, for the sign-up field, this is going to be username and password. And then the context object, this is passed to every resolver and has things like connections to the database and so on. And then this resolve info object, this has a lot of information about the GraphQL schema, the query, an AST, abstract syntax tree representation of the query, and so on. We're not going to do much with that today, but it is there. Okay, so the first thing we want to do is hash the password. Let's just change this in place. We'll say args.password is going to be hashed version of the password. And then the second parameter here is the number of salt iterations, I think it is. Hash sync salt. We've specified it as a number, then a salt will be generated. Okay, cool. And then the number of specified rounds used. Cool. So a salt, that's like a thing that's added to the password when it gets hashed for added security. So someone can't just do like a dictionary attack where they hash a whole bunch of passwords and then try to log in or compare them with the hashed password in the database, because they would also have to generate the salt that gets hashed as well. Okay, cool. So now we're going to create this user in the database. So let's create a session. And we're going to execute this query. So session.run. And our query is going to create a user and set that user node equal to the arguments that we're passing. And then we'll also generate a ID for the user. So Cipher has this random UUID function, so that will generate a user ID. And then we'll return the user from the Cipher query. We need to pass the args object as parameters for the Cipher query. That'll give us a promise, which we can then close the session. We always want to make sure that we close the database session so that frees up connections to the database. And then we want the ID and the username, because we're going to need to return this from this mutation. So that's going to be response.records, which gives us an array of results. And we're just going to have one, so we'll take the first one. And we're interested in the U column of this query. So that's U, the user that we've returned here. And then the JavaScript driver result objects, we can call dot properties on those to give us just a JavaScript object representation of those properties. And then we're just grabbing the ID and username out of that object. And then we're ready to return an object that has a key token. Remember, this is returning, so this mutation, this is the sign up mutation that we're writing, and we're returning an auth token object that has only one field, just a token field for now. I don't know. We might add something to the auth token type, but for now, it just has a token field. And so here we need to generate the JWT. So we'll say JWT.sign. What do we want to sign? So this is the payload or the claims of our token. So in this case, it's going to be the user ID and the username. And here we need a secret. So this is the secret that we're using to sign this token with. By default, we're using the HS256. This is Bcrypt. We want JSON Web Token sign. Right, so we need the secret or the private key. I think by default, we're using the HS256 algorithm, which uses a symmetric key to sign it and to decode it If we were using something like the RSA algorithm, which is a bit more secure, we have a public and a private key. We sign it with the private key, decode it with the public key. In this case, let's keep things simple for us. We'll use the default algorithm. So we need to generate a 256-bit random string. We'll just use this random keygen. That generates a bunch of random strings for us. 256-bit key, sure, that looks good. Okay, and I'm going to save this. Let's save that file. I'm going to save this in our .env file where we have things like the connection string to the database and so on. I'm going to create a JWT secret environment variable and store that there. And then up here, do we read in any environment variables? We just call process.env inline. Yeah, okay, that's fine. That works. Here we go. Okay, so we're signing our token. We need the key process env JWT secret. So that's the secret we're signing it with. And then we need to pass some, let's look at the docs here, some configuration so we can override the algorithm, but we need an expiration. Let's say expires in, how about 30 days? So this token is valid for 30 days. Okay, is this going to work? I think so. Let's fire up our API. Here's our API. Make sure we can still search for podcasts. Search for Neo4j. Yep, there's our Neo4j podcast. Cool. So now if we look at the docs tab for our API, let's refresh this maybe. So yeah, we needed to refresh GraphQL Playground so it picked up our new endpoint here, sign up and log in. Note that it also created an auth token query field and create delete mutations as well. That's part of, by default, Neo4j GraphQL.js. That's this library. By default, will create read, update, delete operations for any type that we declare in the schema. So we want to make sure down here where we're excluding types from the query and mutation augmentation process. Let's exclude auth token. We don't want to generate, oops, it should be an array of strings, not just one big string. So we restart our server, refresh playgrounds. Cool. And those go away, and now we have sign up and login. So let's give this a try. We need to say mutation, since by default the operation type is query, but this is a mutation operation. So we're going to sign up, username. I'll make this a bit bigger. Oh, maybe that's too big. Username, how about Johnny Montana? And our password is going to be let me in. And then this returns an auth token that has a single field token So we'll use that for the selection set. So now when I run this, this should do a couple of things. It should create a user node in the database with the username Johnny Montana. It should hash the password that we've provided and save that in the database as well, the hashed version of the password, not the plain text version. It should generate a random UUID string for the user, and it should create a JSON web token and return that token in the GraphQL operation. So let's see if that happens. No. It says, do not know how to handle this type of mutation. Mutation does not follow naming convention. Well, what did we do wrong here? Oh, right. So we created this resolver, this resolvers map. And then here we're creating our GraphQL executable schema object with the help of make augmented schema. So this is a function from Neo4j GraphQL JS up here, make augmented schema. And make augmented schema takes type definitions and GraphQL type definitions. So that's these type definitions, and then generates resolvers automatically for us. So that's why we didn't pass resolvers before, but now we have resolvers that we've written manually, so we need to pass those as well to make augmented schema. So it didn't know that we had written this resolver function because we weren't passing it to make augmented schema to attach to our schema object that we are then down here serving with the Apollo server. Okay, so let's see if that made a difference. Cool. Okay, so I get back a token. Let's copy this token and take this over to JWT.io. And if we paste this in, we have two things that we're interested in the claims and the payload. We have an ID for the user and the username of the user. Okay, so that looks good. The token looks correct. The other thing we want to check is in Neo4j if we created this user node. And it looks like we did. So here's the UUID that was generated for this user. Here's the hashed password and the username. Change the caption here to username so we see who this is. And make it a bit bigger. Cool. So we can see the username. Okay, that's good. So we can now sign up in the GraphQL API. The next thing that we need to do is implement the login mutation. So a user has signed up. We get the token. They can start making authenticated requests to the API. Let's do the case where they come back a week later, whatever, and they want to log in. So the user already exists. How do we log in? So let's go back to our resolvers here. So we've implemented the sign up resolver. Now we're going to implement the login resolver. So a question in the chat. So related to our earlier discussion about creating databases, when I try creating a database, have the message error statement, not system database error. Yeah, so you want to make sure that you're using the system database. So in the browser, in Neo4j Browser, you want to be connected to the system database when you're doing operations like creating databases. So first, either in this dropdown, make sure you've selected system, and then run the command create database, my database. I think that might be your error. If you're using like the Neo4j default database, and you say create database, my db2, that works too as well. What was the error you're getting? Not system database error. Oh, you're trying to create database. Is that a default or a bad name? Can you not have underscores in the database names? You're saying create database, excursion, agency. Yeah, so I think that's the problem that you're having, is you can't have underscores in your database name. So you might want to call it something like this, excursion agency. And then I can say use excursion agency. Yeah, so try that. Try just removing the underscore from your database name. But yeah, so by the error message, I was thinking that your error had something to do with not being connected to the system database when you make that request, but it looks like you don't need to be anyway. Cool, so try that and let us know if that works. Okay, so we want to implement our login resolver. So this login resolver is passed the same arguments. And in this case, we're going to query the database right away. So let's create a session. So we reference the context object, and we know there's a driver instance in that context object. So if we look here, we're creating the Neo4j driver instance. This is just a Neo4j JavaScript driver that is connected to the database we're using. And then here, when we call Apollo server, we construct the context object, and we are inserting that driver instance. So we can take advantage of that in our resolver to create a connection to the database. Okay, and then we're going to run our query. And in this case, we're going to match on the user. Let's look them up by username. And make sure to just return one user object, and then username Cipher parameter is going to be the username from the GraphQL field arguments. So remember, our field arguments are username and password. Okay, that gives us a promise, which is past the response. Close our session. And we have the user object, so we're interested in the ID, the username, and the password from the result of our query. So result records gives us an array. There's only one record that we're returning. Just in the U column, again, we'll call .properties to give us a JavaScript object. Okay, so now what we're going to do, so this, where it says password, this is the hashed password that we stored in the database. So what we want to do is, whoops, if not compare sync args.password and the password. So compare sync, this is a function from Bcrypt that will compare our hashed password to the password that the user has passed. So args.password, this is coming from the args object, so the field arguments on the login GraphQL field, with password, which is the hashed password that is stored in the database. So we're going to compare those two. If they don't match, then I guess let's just throw an error. We can talk about error handling later, but let's just say authorization error. Okay, now if we're down here, that means that those passwords did match. And now we want to generate a token. So what are we going to return? We're going to return an object that has a single field. Remember, we're returning auth token, right? So login mutation field returns an auth token type. It has a single field token. So we're going to use jwt.sign to take the payload, which is the ID and username for the user who just successfully logged in. We want the JWT secret to use to sign that. And then we will say this expires in 30 days. Okay. Should we try that now? I think that should work. So let's comment out our signup mutation. And now we'll do a mutation to log in. Username, Johnny Montana. And our password was let me in. Let's put in the wrong password first and see what happens. So this should throw an authorization error. Cannot read property of undefined. That doesn't sound like what we want. So I think what happened here is it got through the query and it got down here and tried to look up a user and couldn't find anything. So we should wrap this with some proper error handling. I think the reason is we were looking at a property called user on the user node instead of username. We'll talk about better error handling later. Let's just get this working first of all. So okay, so now I'm trying to log in again with a bad password. And still says cannot get property get of undefined, so it didn't find anything here. Let's see, let's look at our database. Here's our user node. ID password. I do have username, Johnny Montana. Match user, username. So if I run this query, I say match where the username is Johnny Montana. Yep, get my user, okay. This is on line 65. So this is before we get to the password comparison. So it's not because I'm not passing the right password. I know that. That's fine. Did we not restart our server after I made that change? I think I did. Let's try again. Oh, same error. Oh yeah, I do. Thanks for pointing that out. I do have a typo. For some reason I couldn't see that. Johny Montana. There we go. Thanks. Good to have some other folks looking at it with me. That's helpful. Okay, cool. So now I get authorization error because I have a bogus password. If I change the password, I get my token. Cool. And if I take the token, copy this, and go to JWTIO. Again, you can see, oops, it says it's not encoded correctly, copied a couple extra characters. There we go. It says, yep, here's the payload. Okay, cool. So now I've got the ability to sign in to create users, and I can log in to my API and get a token. That's good. The next thing I want to do is now start making authenticated requests to the API. So let's add a query field. Oops, that collapse didn't work too well. Just created some new lines for us. That's okay. Let's add a query field here. Let's just call this me. So this is just going to give us the authenticated user. And first we need we haven't added a user type. So let's add the user type. So a user is going to have a username and an ID. Now there's also a password property, but I don't think we want to expose that. And we also don't want to add the generated query and mutation fields for this user type. So let's add user to our list of types that we are excluding from the schema augmentation process. Okay, so what is this statement spelling? Having a hard time spelling today. Okay, so what is this statement going to be that is the Cipher directive on this me, maybe instead of me, let's call it current user to make it more clear what this is. So what I want to do here is find the currently authenticated user and return that user's username and ID, essentially, that object. Well, let's take a look at the docs. What I want to look at here, let's make this a little bigger. I want the docs, is this in the guides perhaps? Yeah, adding custom logic. So the Cipher schema directive, so far we can use this to create computed fields. We also did this for top level query fields, right? So that's what our podcast search is here. And we said that the field arguments are passed into this Cipher query that is attached to the GraphQL field as Cipher parameters. So here, this is like a fuzzy text search where we're passing in some search string as a field argument on the GraphQL field. And this search string is then injected into this Cipher statement as a Cipher parameter. So that's how Cipher parameters are injected into those Cipher directive statements. But if we take a look at the authorization middleware, and I specifically am interested in Cipher parameters from context. So another way that we can inject values into the Cipher statements in the Cipher directives is in the context object. So we saw just a second ago how we create the context object here when we call Apollo server. And in this case, we're injecting a driver instance. But another thing we can do is treat this as kind of like middleware. And when a request comes in, we can look at the headers in the request, which is typically where a authorization token, that's a typical pattern, is to add the authorization token as a bearer token, so as a header in our request. We can inspect those headers, grab that token, add it into the context object, and then that will be available in the Cipher query that we're attaching to this GraphQL field here. So when we make the request in Playgrounds, what we'll do, let's comment out this one. Oops. So we'll say something like current user, username and ID. And then in the headers, we'll add an authorization header as a bearer token. So the convention here is to say bearer, and then we paste our token. So then when the request comes in, what I want to do in the context object, so here we're returning an object, but this can also be a function. So this function is past the request object. And then we can return some things, but first, so like return driver and the name of the database that we want to use. But what I want to do now is, okay, so there's this authorization token attached to the request headers. What I want to do is grab that token and then decode the token and grab the claims out of it. So I want to grab the user ID out of that so that the user ID is then passed as a parameter into this Cipher query. And I can use that in my Cipher query to look up the user, if that makes sense. So in this context function now, I'm going to get the token. So it's going to be the request.headers.authorization. So that's going to give me this piece, but I need to strip out bearer. So was that B-E-A-R-E-R space. So I need to strip out 7 characters. And then I'm not always, I still want to be able to make unauthenticated requests, right? So I don't want to throw an error if I don't have an authorization header. So let's add the optional, what's this called? Optional chaining, I think. So check to make sure that we have a headers object and an authorization object before we try to slice it. Okay, so now token should be the actual JWT token. And now what I want to do is get the user ID. So I'm going to create a user ID variable. I'm going to say if we have a token, then let's decode it. So jwt.verify. If we look at our docs for JSON Web Token, verify takes the token and our secret. And if a callback is not supplied, it acts asynchronously and returns the payload decoded if the signature is valid. If it's not valid, then it throws an error. Okay, cool. So we can try to decode it with the token, and our secret is process env jwt secret. And then we'll say the user ID is decoded.id. And then this is the object I want to return. Let's format that. And I want to return the driver. And then in the docs for GRANDstack, where's that here? It says anything in this Cipher params object is injected into our Cipher query as a Cipher parameter called Cipher params. So I want Cipher params or I'm passing in, let's do camel case here, I think, to be consistent. Okay, does that make sense? So if we have an authorization token in the headers, then we'll decode that. If it happens to be a bogus token, like if it's not actually signed by our application, then we'll throw an error. That's good. That's what we want. We don't want someone trying to send us a bogus token. We'll decode it. We'll grab the user ID out of the token payload. And now in our context object, we'll add this Cipher params object that has the user ID from the token. So now, if we go back to our GraphQL schema, we should be able to say match user by ID, where the user ID is Cipher params dot user ID and return the user node. So let's refresh Playground so that it picks up our schema change. So yep, cool. We've got current user. That's going to give us user objects. And we added the user type to the list of types that we're excluding from the schema augmentation process for Neo4j GraphQL.js. So that's why we don't have the CRUD GraphQL operations for the user type, even though we added that into our schema here. We've got our authorization token from our previous login request, so that should still be valid. And we're going to make this current user request. Cool, looks like that worked. So it says, here's your user ID, and the current user is Johnny Montana. Let's create a different user, make sure this works. So we'll go through this process again. So here, let's sign up to create a new user called, this one will be username JennyCat. Password is feedme. So let's also, we have the authorization token that we're sending here, which I guess is okay. Let's just take that out, since that seems kind of odd to be sending an authorization token when we are going through the sign up. I don't think that will impact anything. Like, we will still go through the decoding process of the token, and it'll be passed along as a Cipher parameter, but in the context, but we aren't accessing it. But it seems odd, so we'll remove that. Anyway, so okay, let's run that. And cool, it says here's your token for JennyCat. If we go to the database, and now we look at our user nodes. Cool, yep, we've got one for JennyCat with that user's generated ID and the salted password, along with Johnny Montana. And if we take this token and add that as an authorization header, and now we don't need to do login because we have the token. That's fine, although we can test it. But let's do current user, passing the token, and we should now have username JennyCat. Cool, so that works. Okay, cool. So we've implemented user login and user sign up. We said we also wanted to implement subscribe. So we wanted to be able, we want a user to be able to subscribe to podcasts, right? So let's see. What we can do in our schema is now add a mutation. Let's say subscribe to podcast. And this is going to take a iTunes ID, I think. And let's have it return a podcast type, which we haven't added yet. So let's create a type podcast. So if you remember, let's do a podcast search here, which I don't have an example. That's fine. Podcast search term, Neo4j, title, feed URL, description, iTunes ID. So because iTunes has the largest podcast index, we treat that as the canonical ID for a podcast. So in our application, we're going to have users searching for podcasts by search term. They're going to see this like list of here are all the podcasts that you may be interested in. And then they're going to say, yep, I want to subscribe to that. And on the back end, what's going to happen is we're going to send this iTunes ID to this subscribe to podcast mutation. And that is going to update the database. It's going to do a couple of things. One, it's going to grab the currently authenticated user using the Cipher parameters and the Auth token that's passed as a header. And then it's going to merge the podcast node, because remember, the podcast search, this query field, this isn't actually creating any data in the database. This is just going out to the podcast index and searching and passing through results. But we haven't actually created any podcast nodes in the database. So we want to make sure that our subscribe to podcast mutation merges on the podcast node. So if it doesn't exist, we want to create it. So we'll use the iTunes ID to refer to that podcast. So anyway, so the fields that we need are an iTunes ID, podcasts have a title, a link, so like a web URL. They have a feed URL. What else? Description and image. That's probably good enough for now. So then our subscribe to podcast, this is going to be a Cipher directive field. In our Cipher statement, well, the first thing it's going to do is match on the user. Look up user by ID, and we have Cipher params dot user ID to find the user. And then we're going to merge on the podcast. Since we may not have saved this podcast in the database yet, so that's why we're doing a merge. So a merge is going to create it if it doesn't exist, but not create a duplicate if it already exists. That's the benefit of merge. And the value for this is going to be iTunes ID as a Cipher parameter. That's this value here that the user is passing in. And then we want to create a relationship. Say that the user subscribes to this podcast. And then we need to return the podcast. let's save that. And refresh Playground to pick up our schema changes. And now we can say mutation, subscribe to podcast, iTunes ID. Oh, we need an iTunes ID. Let's go back here, search for the Neo4j podcast. So we're going to subscribe to the Neo4j podcast with our currently authenticated user, which this should be the JennyCat user. And that gives me a podcast object. So let's get the iTunes ID. So if this works, we should create a new podcast node in the database to represent the Neo4j Graphistania podcast, and then create a relationship from JennyCat to that podcast saying that JennyCat has subscribed to it. So it returns the iTunes ID. Let's check the database to see if we create anything. Yep, cool. So JennyCat now subscribes to this podcast that just has an iTunes ID. So there's something that we're missing here, which is the only information we have about this podcast is its iTunes ID, which is not very helpful for building our application, right? It's like we want the name of the podcast. We want to know the feed URL, because eventually we're going to have to go out and parse the feed URL to find the actual episodes, right? So let's take advantage of the podcast index. So here we're making a call to the podcast index to search for podcasts by term. But I think, let's take a look at the documentation. I think we can look up a podcast by feed URL. Yeah, by iTunes ID. Yeah, here we go. So here we can just look up a single podcast by iTunes ID at this endpoint. So let's change this mutation for subscribe to podcast. Let's also make a call to the podcast index API to look up the podcast by iTunes ID and basically get more information about the podcast that we can then store in the database to make available to the application. So we have, I'm just going to do a little copy paste because we have here constructing the authorization header. That was, I think, the most work. The authorization header for the podcast API using Cipher. So let's do that. Let's do that as the first part of the query. So api.podcastindex.org, what is it? Not search, it's podcasts by iTunes ID. By iTunes ID. Got to be extra careful on my spelling today. And the query parameter is not Q, it's ID. And then apox text URL encode. Yeah, we can still URL encode it. That's fine. iTunes ID. Headers are going to be the same. It yields a value. And then what does it yield? We don't need to unwind over anything because there's just a single object. So let's say with value dot, what is it? Value dot feed as feed. Okay, so now what do? We match on the user. That's still good. We merge on the podcast by iTunes ID. That's good. But now we can set to update some properties on this podcast node from the data from the podcast index. So let's set the, what did we say, title. It's going to be feed.title. What did we say here? Title, link, feed URL, description, image. So link, feed dot, we have link and original URL and URL. So link is like a link to like the web page for the podcast, I guess. And URL is, I'm guessing, the RSS feed. Yeah, so link is like the landing web page, and then URL is the RSS feed. So link feed dot link description feed dot description. What else? Feed URL and image. We said p dot feed URL equals feed dot URL. And image equals feed dot what, artwork, I think is what they call it here. Image and artwork. What's the difference? That's the same value, the same image. Yeah. Is artwork like a higher resolution version of image? Maybe, I don't know. Let's go with artwork. Okay, and then I like to line up our equal signs here so I can see what's going on a little bit better. Okay, cool. So that's iTunes ID, title, link, feed URL, description, image. So that's what we're updating as properties in the database. And then we create the subscribes to relationship, return the podcast. Yeah, I think that should be good. Let's save that. And go back to GraphQL Playground over here. I can do this again. I can subscribe to this podcast again, and it shouldn't create any duplicate data because we're merging on iTunes ID. But if I refresh this query, now we can see that we've stored some podcast detail information. So now we have the feed URL, the image, description, and so on for our podcast. Cool. The other thing we need, and I guess I should say now I can also add other fields here. So description, title, feed URL, and so on that I get back from that GraphQL mutation. Neat. So the other thing that we're missing, I think, is being able to get a list of my subscribed podcasts as a user. So we'll add another query field. Should we call this subscribed podcasts? So this is going to be a query field. So I send in my request that has a authorization token. We're going to look up the user in the database, and we're going to see what podcast they subscribe to, if any, and return those. So again, we'll take use of the Cipher params. If you see some flashes in the background, that's just a light bulb that I have that's going out. So don't worry, it's not lightning or anything. Okay, so subscribe podcasts gives me a list of podcast objects, and I'm going to write a Cipher query to fetch podcasts for a user. So first we're going to match on the user by ID using Cipher params dot user ID. And then I want to know what podcast they subscribe to. And I'm just going to return those. And something went wrong with the parser. Oh, I need an argument here called statement for my directive. So we'll refresh GraphQL Playground to pick up our schema changes. And if we look at the docs, we should have a new query field called subscribed podcasts. We could also call it my podcast or something like that. That might be something a bit more fun. So we're passing this authorization token. This is for Jennycat. What podcast does she subscribe to? She subscribes to Graphistania. Cool. Let's test this. Let's go back to podcast search. Let's search for, I don't know, the connected podcast. What's the URL? Here's the iTunes URL for that one. And we'll do our subscribe to podcast. So Jennycat now wants to subscribe to connected. If I check in the database, cool, in the database, now I have connected and its information, description, feed URL, and so on that Jennycat subscribes to. And if I now say, now show me my subscribed podcasts, I get Graphistania and connected. Cool. That seems to be working. Let's test this now for a different user. So I'm going to go back to the login mutation. So for the user Johnny Montana, I'm going to log in. Here's a token that I'm then going to attach to each GraphQL request. So we'll update that in the HTTP headers down here that we're sending as a bearer token. And now if I say current user, I should get Johnny Montana instead of Jennycat. And if I go to my list of subscribed podcasts, I should get an empty list because I don't subscribe to any podcasts. We can check that in the database, but I don't for this user. Let's go and subscribe to the connected podcast. And now if I request my subscribed podcasts, I get just connected, and it's specific for the user Johnny Montana, which is the currently authenticated user, because that user is passing the correct JWT token that is cryptographically signed by our application and includes the correct payload with the user ID for that object, or for that user. And if I come back here, I can see that, yep, Johnny Montana subscribes to this podcast now in the database. Cool. So I think that is the functionality that we wanted to implement. We now are able to have users sign up to our application at least in the API. Again, we haven't looked at the front end yet. Users can sign up, they can log in, they can now subscribe to podcasts, and they can see their list of subscribed podcasts. And we've hydrated those podcasts in the database with data from the podcast search index, but only for the podcasts that our users have subscribed to. Because search goes out to this podcast index service, we don't really care about storing in the database any podcast that one of our users hasn't subscribed to. Cool. So I think that is what we wanted to get done today. So I think we'll leave it there. I will push up the code to GitHub as soon as we're done. I'll link in the chat that GitHub URL, so you have that. Next time, I'm not sure what we should cover next time. We have a few things that we need to dig into. We need to parse the feed URLs somehow, because the next thing that a user is going to want to do is see the episodes for a podcast. We also need to think about playlists. So a user can create a playlist and add episodes to it. We also need to think about the front end of our application, because we haven't really done anything with the front end yet. So I don't know. We'll take a look at some of those, or I should say at least one of those features. Uday says we need episode recommender with graph data science. Yeah, we do. Definitely. That is something we will definitely get to along the way once we have some episodes. I was thinking it would be interesting to try to transcribe some of these. So is there some, not text to speech, but the other way, speech to text, that we could do, and then we could apply some NLP techniques, maybe some graph algorithms for recommendations. So we'll get there eventually, but we need to build out some of the other functionality first before we start digging into things like that. But definitely want to take a look at that. Well, cool. That's all for today. Thanks for joining, everyone. We will see you next Thursday at 2 p.m. Pacific on the Neo4j stream. So thanks a lot for joining. Let me know on Twitter if you have ideas for what the next episode should be, which feature we should focus on. But otherwise, thanks for joining, and we'll see you next time. Cheers.